say, "Bro, why are you on a bus? This is the math video." Well, there's two reasons. The first one is the bus is a great way to get around. You got a driver taking you places. You can go to the museum, the beach, the mall, the park, the movies, your friend's house. Second off, to be on a bus, you gotta know where you're going. You have to know how to read a map. You gotta be able to tell directions. Basically, you gotta know the coordinate system.
A coordinate system is a method of locating points in a plane or space by means of numbers.
I'm talking about points, X and Y axes. So it's another thing about math that's related to the real world. So let's check it out. Over the years, people have used various systems to show where places or objects are around the world. But about 400 years ago, a French philosopher named René Descartes revolutionized mathematics by linking algebra to geometry. Basically, he connected the real world to mathematics. And one of his biggest contributions was the Cartesian coordinate system. And what the Cartesian coordinate system does is it specifies a point or object on any surface. In other words, he's telling us where everything and anything is. And the surface can be a piece of paper, a classroom, a city, a country, the world. It could even be space. You might be thinking, why is the coordinate system so important? What do you mean, it revolutionized mathematics? It's just a bunch of lines. Well, with these bunch of lines, we're able to create mathematical equations to describe or show lines and curves, and where points are around us. In other words, we can create a mathematical equation for almost everything you see and do. Let me explain. There are different types of coordinate systems. There is the polar coordinate, the spherical coordinate, the homogeneous coordinate, and a few more. They all help us visualize lines, curves, and shapes using mathematics. For example, we can trace the motion of a ball and create an equation to predict where it will go next. Video games use coordinates to create the motion and graphics you see in the real world. With coordinates and today's technology, we can create equations to help us build structures and preview and test our ideas before actually creating them. Planes, trains, automobiles, and other transportation use coordinates to show where we are or where we need to go and help us determine the distance from one point to another. Today we can find anything and everything with a click of a button, thanks to coordinates. But the father and most widely used is the Cartesian coordinate system. It can be used in two-dimensional or three-dimensional space. The equation x squared plus y squared equals 9 actually describes a circle with a radius of 3. The system uses two axes, or perpendicular lines, to create a space to show where points lie. These axes are normally called the x-axis, which is the horizontal line, and the y-axis, which is the vertical line. If we go 3D, we normally use another line called the z-axis. All of these lines are perpendicular to each other. We mark points using coordinates. If we wanted to show where P is on the coordinate system, we would say it is at 3, 5, because it is 3 across and 5 up. Well, I hope that helps, but let's take a better look. Follow me.
x-axis goes horizontal, and the y-axis goes vertical. And where they meet, it's called the origin. And at that point, the x and the y equal 0. It's the starting point. Let's do a couple of examples so we can learn more about the coordinate system.
We can make this simple and create a number line by using the x-axis. And we can place points there. See, x equals -1, or x equals 3. They're just points on a line. But we can create another axis, the y-axis. And now our points can be placed anywhere in this space or plane. If you look closely, you can see our coordinate system is separated into 4 sections. We use Roman numerals to label them 1, 2, 3, and 4, and we call them quadrants. Now, if I place a point in the second quadrant, let's call it F, you can see that it has 2 spaces to the left, which makes -2, and 3 spaces up, which gives us -2, 3. We use parentheses around the numbers, and the x-coordinate always comes before the y. When writing a coordinate, a lot of people forget which number comes first, the x or the y. Here are some helpful ideas to help you remember. X comes before y in the alphabet. If you're going to climb a ladder, it is best to move the ladder first before climbing it. And you have to walk into an elevator before you can go up or down. Again, the x-axis comes before the y-axis. Let's try another one. If we have a point called W placed in the 4th quadrant, we need to go 1 to the right and 4 down, which gives us a coordinate of 1, -4. See how the number across comes before the number down, or the x comes before the y. So, points can lie on a line or a curve. They can be on a polygon or a shape. They can actually represent big objects like your school, house, or car. They can even be you. The Cartesian coordinate system lets us place these points on a plane. Not that kind of plane. I mean a plane which is a flat surface that goes forever and ever in all directions. If we cut a piece out of this plane, we can see it is flat. And if we look at a specific section, we can place our x and y axes to show where the points are.
In the early 1900s, a man named Clifford von Wickler created a game using coordinates. It is a 2-person game where people secretly draw ships on a grid and try to sink the other person's ships. Each person takes turns calling out coordinates like E6 and C4 and mark the locations on their paper, saying miss if a ship is not on the coordinate, and hit if it is. You keep playing until one person's ships have all been sunk. You sank my Battleship. This game was later taken by a large toy company and sold by the millions.
See, points just specify exact locations, and the coordinate system just helps us locate where the points are. Now let's take a look at how we can write equations for more than one point. We can have more than one point on our graph and create equations which tell us where to place certain points. And when we connect these points, we can create lines or shapes. For example, if we have an equation y equals 2x plus 1 and make a table for the x and y coordinates, we can pick any number to put into our equation. Usually it's a good idea to pick a small number. Let's choose 1 for x. Now if I substitute or change all the x's to 1, we get an equation y equals 2 times 1 plus 1, which will make y equal 3. So now we have a point at 1, 3. If I do this a second time, but pick a different number for x, let's say -2, and substitute it into our equation, we now have y equals 2 times -2 plus 1, which will make y equal -3, and give us another point at -2, -3. We now have 2 points, one at 1, 3, and another at -2, -3. And if we connect them together, we can create a line. In other words, y equals 2x plus 1 actually describes this line. It tells us which way it goes and how steep it is, or how fast it rises.
Excuse the interruption, but we just had some breaking news about a super dude flying through the city. Hold on. I've just been told that one of our reporters is now live at the scene of the super dude.
It looks like he is using mathematical equations to calculate the distance of his jumps.
Yes, but do you think he's considered air resistance?
By the looks of it, no.
That's disgusting. I feel sick.
How about another one? Let's use y equals x minus 3. And again, we can create a table for x and y, and randomly pick a number for x. I'll choose 3 first. Then I place or substitute this number into our equation for all the x's and solve for y. So when I'm done, y equals 0. We have our first point, which is 3, 0. But we need another point to create our line, so I need to do this process one more time. This time I'll pick 2, and if I substitute 2 into our equation and solve, I will get y equals -1. And now I have 2 points, one at 3, 0, and another at 2, -1. And if I connect them, I'll get a line that looks like this. Again, y equals x minus 3 describes this line using mathematics. With the coordinate system, we can use math to describe things in the real world. In other words, we can write what a shape looks like using math. By using the coordinates of the points that lie on the shape, we can create an equation that tells us what the shape looks like. What this means is we can take any line in the real world and create an equation for it. Now this is just a simple example, but really, we can take any shape and use math to describe it. See, math is everywhere and anywhere. Oh, hey there! I was taking my bike for a ride and I got lost, so I'm checking my map for directions. You know what? I just realized that this map is based on the Cartesian coordinate system. I mean, it uses a kind of x and y axis to show exactly where I'm at. For example, if we look at this map and someone wanted to know where Fairfield Road meets Kenneth Street, we would tell them it is in grid 1B. Now they can look at the map and see exactly where they meet and what is around those two streets. You know what's even cooler is that this map is based on even a bigger system where people use what's called latitude and longitude to find anything, anywhere around the world. Oh, there I am. Okay, gotta go. See you in a bit. So check this out. In 1960, the United States of America put 5 satellites up in outer space.
3, 2, 1, we have liftoff.
And started the U.S. Space-Based Global Navigation Satellite System. And their idea was to use these satellites and the coordinate system to map the entire planet. And they do this by using imaginary lines called latitude and longitude to create an invisible grid around the Earth. The latitude lines circle the globe from east to west, while the longitude lines run north and south. Well, by 1994, they had 24 satellites up there. And now they can track anything and everything. Global Positioning System. GPS, or Global Positioning System. And guess what? It's totally free. It is used for many reasons, and is becoming more and more useful every day. Well, that's it. I hope you liked the show. And remember, math is everywhere and anywhere. And math is math. It's supposed to be fun.